In this example, we want to determine the value of the limit of x cubed as x tends towards 2. Here, the function is x cubed and a is equal to 2. So what we're going to do is set up a table of values to evaluate f of x at x values that are really close to the number 2. So I'm going to go ahead and choose a couple of values that are close to 2, but are a little bit less than 2. So beginning with 1.9 and going all the way up to 1.9999. And I'm going to take out my calculator and start to evaluate these numbers cubed. So first, let's take 1.9 cubed. Converting this fraction into a decimal, we get about 6.859. Next, let's go back and evaluate 1.99 cubed. And in this case, we get about 7.88. Next, 1.999 cubed gives us about 7.988. And finally, 1.9999 cubed evaluates to about 7.9988. So looking at our table of values here, it appears that as a gets closer to 2 for values that are a little bit smaller than 2, it looks like a cubed is tending towards the number 8. Let's go ahead and repeat the process, but now we're going to choose values a little bit bigger than 2, but still really close to the number 2. So beginning with 2.1 and going all the way down to 2.0001. Taking out our calculator and evaluating 2.1 cubed and converting that fraction to a decimal gives us 9.261. 2.01 cubed gives us around 8.12. 2.001 cubed gives us about 8.012. And finally, 2.0001 cubed gives us about 8.0012. So once again, we see that the a cubed values do tend towards 8 as well. We just get decimal numbers that are a little bit bigger than the number 8. So we can see that when we start to take x values that are in the neighborhood of 2, like they could be a little bit larger or a little bit smaller than the number 2, all of our x cubed values tend to get very close to 8. A little bit bigger than 8, or maybe a little bit smaller than 8. But we can probably conclude here that as x tends towards 2, x cubed tends towards 8. So we write the limit as x approaches 2 of x cubed is equal to 8.